chemical reaction. Their physical chemical property is different. They are coded from the different gene, and they are in the polymorphic form, means different forms. Structure is also not similar, but the function is same. Like examples: LDH, lactate dehydrogenase; creatine phosphokinase; ALP, alcohol dehydrogenase, etc. Glucokinase, hexokinase. Our body contains many isoenzymes, and these are few important examples. And it can be the role of isoenzymes can be discussed as a biological role and diagnostic role. So biological role ma okay, कसले भन्न सक्छौ glucokinase र hexokinase, what is the biological role of these two isoenzymes, although their function is same. What is the main function of glucokinase and hexokinase? Although they catalyze same chemical reaction to convert glucose to glucose 6-phosphate. So what is the difference between these two? What is their role? So can tell me. Balkrishna, can you tell me?
हजुर सर, ग्लुकोकाइनेजले चाहिँ लिभरमा काम गर्छ हैन.
Okay, glucokinase works in liver, hexokinase
एक्जोकाइनेजले चाहिँ मसलमा काम गर्छ.
muscle काम गर्छ. Okay, के काम गर्छ?
ग्लुकोजलाई ग्लुकोज 6 फोस्फेटमा लैजाने.
Okay, ग्लुकोजलाई ग्लुकोज 6 फस्फेटमा लाने काम गर्छ भनेपछि अनि रोल के डिफरेन्स भयो त? त्यसको इम्पोर्टेन्स टिस्युमा हुनु र लिभरमा हुनुको इम्पोर्टेन्स त हुनु पर्यो नि, नत्र भने एउटै इन्जाइम भए पुगिहाल्थ्यो. किन दुईटा डिफ्रेन्ट आइसो इन्जाइम्स हुनु पर्यो? ल विनिता भन्दैौ तिमीले.
ग्लुकोकाइनेजमा चाहिँ ट्र्यापिङ अफ ग्लुकोज र कन्भर्जन टु ग्लाइकोजेन हुन्छ. अनि एक्जोकाइनेजमा चाहिँ ग्लाइकोलाइसिस र एटीपी प्रोडक्सन मात्र हुन्छ.
Okay, that is the
muscle energy.
Okay, it means glucokinase works to maintain blood glucose level.
Yes.
It is only active when blood glucose level is high, and when the blood glucose level falls, again the glucokinase becomes inactive because it has high Km for glucose. Km value भनेको. Then in case of hexokinase, it is always active. Even at the normal blood glucose concentration, hexokinase is active, while glucokinase is inactive. So hexokinase is always saturated and always active, and its role in the muscle is to promote glycolysis, so that muscle there will be continuous supply of energy to the muscle, because our muscle is continuously being under contraction and relaxation. So it means that muscle always require energy. So that's why hexokinase should always remain active. So that is the main biological role of glucokinase and hexokinase. So as you can see in this diagram table as well, tissue distribution, Km value, substrate specificity, glucokinase is only specific to glucose, whereas hexokinase can break down glucose, fructose, galactose. Substrate inhibition, there is no inhibition of glucokinase but inhibited by glucose 6-phosphate, which controls the rate of glycolysis. Insulin induces glucokinase but hexokinase has no effect. Biological role, अघि मैले भनिहालेँ, यो trapping up glucose and maintains blood glucose level when there is hyperglycemia, and this provides ATP by glycolysis. So this is the biological role. Now let's see about diagnostic role. So diagnostic role, as I have already told you, that their distribution is different. That is, they are differentially distributed in different tissue. So by measuring isoenzymes, we can identify the source of the enzyme. That is, which one of the tissue is damaged or injured. So that information we can derive by measuring the isoenzymes in the blood. So they can also serve as a marker of tissue damage. It means the same thing. Marker means if the tissue gets damaged, then the particular enzyme which is present in that tissue will be elevated. So it means that these are the marker of that tissue. Separation and measurement of isoenzymes can be done by various methods, like we have electrophoresis, chromatography, densitometry. These can be applied. However, we also have the normal chemical method for the measurement of isoenzymes. So in the practical also we will measure one of the isoenzyme, CKMB and measure also. So now let's begin with isoenzymes and their diagnostic role. First is creatine phosphokinase, abbreviated as CPK, and this is the normal level, less than 100 international unit per liter. Function: it catalyzes the formation of creatine phosphate, reversible formation of phosphocreatine. So creatine can be phosphorylated, at the same time phosphocreatine can be dephosphorylated to creatine, and this kind of phosphorylation-dephosphorylation reaction is catalyzed by creatine phosphokinase, and ATP is required for this phosphorylation. Or we can say that phosphocreatine is the storage form of high energy in the muscle, which provides immediate source of energy. Its role is equivalent to ATP. The function of ATP is also to provide energy, and the function of phosphocreatine is also to provide energy, especially in the muscle, because our muscle needs immediate source of energy, which is supplied by this phosphocreatine. There are three isoenzymes with two types of polypeptide, M and B. So M means muscle specific polypeptide, B means brain specific polypeptide. Now you can see in this diagram, CK1, also called CKBB, because it is composed of two B and B polypeptide. It is present in brain, elevated in CNS disorder, GI disorder and certain tumors. This is CK2, also called CKMB. So it has two types of polypeptide, M type and B type, predominant in myocardium, in the heart muscle. So it increases in myocardial infarction as well as in the hypothyroidism. CK3, also called CKMM, it contains two muscle type of polypeptide. So it is abundantly present in skeletal muscle as well as a small amount is present in myocardium. So it is mainly elevated in muscular disease like muscular dystrophy, myopathies, hypothyroidism. So these are the conditions where different isoenzymes will be elevated. So actually in the clinical laboratory we don't do this CKBB and CKMM. We most commonly we perform CKMB because it is a sensitive and specific marker to heart disease. किनभने heart problem that is the major problem, and CKMB or CK2 its major source is heart. So that's why we preferentially measure CKMB in the laboratory to identify whether the person is having heart myocardial infarction or not, because it is specific to heart. So यसरी चाहिँ हामी अब यहाँ टोटल CK मेजर गर्यो भने CK1, CK2, CK3 तीनटैको भ्यालु आउँछ र टोटल CK चाहिँ बढ्या छ। के भएर बढ्यो त? It may be due to muscle injury, it may be due to vigorous exercise, it may be due to hypothyroidism, it may be due to myocardial infarction. We cannot distinguish what actually is elevating the total creatine phosphokinase. So that's the measurement. I don't know the reason behind it. So now what we want to do, we want to identify the main cause. What actually is causing the total enzyme to increase? So we can measure the isoenzymes and we can easily identify which fraction of the isoenzyme is increasing. जस्तै CK1 बढेको भने पनि CK बढ्छ, CK2 बढ्यो भने पनि टोटल इन्जाइम बढी नै हुन्छ, CK3 बढ्यो भने पनि बढी नै हुन्छ। अब आइसोएन्जाइम मेजर गरेपछि CKMB ले गर्दा टोटल इन्जाइम बढेको हो कि यसले गर्दा बढेको हो कि यो MM ले गर्दा बढेको हो भनेर हामी पत्ता लगाउन सक्छौं. So it just helps us to clarify our confusion. Okay. Another is lactate dehydrogenase, or also called LDH. It catalyzes the reversible conversion of pyruvate to lactate. So you might have seen in the glycolysis, pyruvate to lactate conversion or lactate to pyruvate conversion is catalyzed by lactate dehydrogenase. It has 5 isoenzymes, and these isoenzymes are made up of 2 types of polypeptide, H and M. H means hard type, means muscle type. भएर बस्न सक्छ. So based on that, we have 5 different types of LDH5. LDH1 2 heart and 2 muscle polypeptide, LDH4 1 heart 3 muscle, and LDH5 4 muscle type of polypeptide. So these are the isoenzymes of LDH1 through 5, and this is their distribution. LDH4 mainly heart मा पाइदो रहेछ, LDH2 heart र RBC मै हुन्छ यो पनि, LDH3 brain, kidney, LDH4 liver, skeletal muscle, spleen, lungs, and LDH5 चाहिँ mainly skeletal muscle and liver मा पाइन्छ. So यसबाट पनि हामीलाई के थाहा हुन्छ, अब टोटल LDH मेजर गर्यौं भने बढेको देखिन्छ. तर के कारणले बढेको? हार्टको डिजिजले नि बढेको हुन सक्ने, हेमोलाइसिसले नि गर्दा बढेको हुन सक्छ, स्केलेटल मसलबाट बढेको हुन सक्छ. So in this case we have to measure isoenzyme. What actually is causing the LDH to increase? त्यसको लागि यो टेबलमा हेरौं. LDH1 will be elevated in the myocardial infarction यदि हार्टको इन्भल्भमेन्ट रहेछ भने. LDH2 will increase in the megaloblastic anemia, leukemia. LDH3 leukemia, LDH4 pulmonary infarction, LDH5 skeletal muscle and liver disease हरुमा बढ्दो रहेछ. ओके, सो यसरी चाहिँ डिफरेन्ट आइसोएन्जाइम मेजर गरेर कहाँनिर बढेको भन्ने कुरा हामी पत्ता लगाउन सक्छौं. यहाँ बीचमा डिस्कनेक्ट भएको रहेछ. मेरो आवाज सुनेछ?
सुनेछ सर. सुनेछ सर.
त्यसपछि यो ल्याक्टेट डिहाइड्रोजिनेज भयो. अर्को छ ALP or अल्कलाइन फस्फेटेज. सो यसको पनि फंक्सनहरु त्यही नै हो. Hydrolysis of the phosphate at alkaline pH. Distribution widespread, but highest concentration occurs in intestinal epithelium, kidney, bone, as well as in the liver and placenta. यसको distribution कहाँ पाइन्छ भन्ने कुराहरु. Reference range: adult up to 300 unit per liter, whereas children up to 600 unit per liter. And its clinical utility is evaluation of hepatobiliary and bone disorder, because the major source of ALP is hepatobiliary system as well as the bone. So यो दुईटा मध्ये कुनै पनि डिसअर्डरहरु भयो भने ALP को लेभल एकदमै हाई हुन्छ. So that's why it is mainly specific to hepatobiliary and bone disorder. जस्तै hepatobiliary मा पनि mainly extra hepatic obstruction जस्तो गल स्टोन्स हरु भयो, बाइलेरी स्ट्रक्चरहरु भयो, जुन हेपाटोबाइलेरी सिस्टममा कुनै obstruction भयो अथवा त्यहाँ कुनै ड्यामेज भयो भने त्यसलाई चाहिँ ALP ले आइडेन्टिफाई गर्छ. र त्यो बाहेक बोन डिसअर्डरहरु, मेनली ओस्टियोब्लास्टिक डिसअर्डरहरु, बोन डिफर्मेसन डिसअर्डरहरु जस्तै प्याजेट्स डिजिजहरु भयो, अनि त्यस्तो किसिमको कुनै पनि बोन डिसअर्डरहरु जसमा ओस्टियोब्लास्टहरु एक्टिभ हुने, डिस्ट्रोय हुने कन्डिसनहरु हुन्छ भने इन दैट केस ALP इन्क्रिजेस. अब यसमा यहाँनिर फेरि प्रब्लम के भयो अर्को भने ALP त बढ्या छ. So we exactly don't know what is the source of ALP, whether it is originating from the hepatobiliary system or whether it is coming from the bone. So we don't know. के भने त अब हामी फेरि यसको आइसोएन्जाइम मेजर गर्न सक्छौं. बोन स्पेसिफिक आइसोएन्जाइम, बाय हेपाटिक लिभर स्पेसिफिक आइसोएन्जाइम्सहरु हामी मेजर गर्न सक्छौं जस्तै यसमा हेर these are 5 different types of isoenzymes of ALP alpha 1 it is found in the hepatobiliary system epithelial cells of biliary canaliculi so alpha 1 बढेको तुरुन्तै थाहा हुन्छ कि alpha 2 heat stable found in the placenta so it is very sensitive to heat but this is stable to heat त्यस्तै गरी pre beta ALP found in the bone osteoblast so it increases in the rickets osteomalacia Paget's disease etc त्यस्तै गरी gamma ALP is found in the intestinal cell so in this way just by measuring the isoenzyme we can easily exclude the causes of ALP elevation. Another is acid phosphatase function hydrolysis of phosphate at acidic pH so ALP ले alkaline pH मा break गर्थ्यो भने यसले acidic pH tissue distribution widely found but high concentration occurs in prostate gland liver spleen bone mainly in the osteoclast RBC and WBC त्यस्तै गरी reference range up to 12 unit per liter clinical utility evaluation of prostate cancer bone metastasis and Paget's disease अब यो एसिड फस्फेटेज खासै हामी आजकल गर्दैनौं यो भन्दा राम्रो टेस्टहरु आइसकेको छ तर पनि पहिला पहिला यसलाई हामीले प्रोस्टेट क्यान्सरको लागि हैन त्यसको लागि इभ्यालुएसन गर्छौं बिकज प्रोस्टेट इज वन अफ द मेजर सोर्सेस अफ एसिड फस्फेटेज त्यो बाहेक बोन के ट्युमरहरु छ भने अथवा कुनै पनि किसिमको बोन डिसअर्डरहरु छ भने पनि हामी एसिड फस्फेटेज मेजर गर्छौं बट नाउडेज इट इज not recommended. It is not used. It is obsolete, and it is replaced by other very sensitive and specific enzyme. So I will not go in detail about this enzyme. त्यसपछि आयो amylase. So it is widely done test. The function is to hydrolyze polysaccharide mainly glycogen and starch. Carbohydrate digestion मा use हुने enzyme हो. Tissue distribution major source भनेको pancreas and salivary gland these are the major source minor sources are like fallopian tube lungs and muscle reference range up to 140 unit per liter so whereas it is also found in urine where it is less than 400 unit per liter so this is the only enzyme which is found in the urine because of its smaller size no other enzymes can be found in urine so it means that we have another chance of detection of amylase एउटा चाहिँ ब्लड मा हामी डिटेक्ट गर्न सक्छौं अर्को युरिन मा पनि हामी डिटेक्ट गर्न सक्छौं so that is the additional benefit of amylase clinical utility diagnosis of acute pancreatitis where the pancreatic amylase will increase अर्को भनेको salivary gland lesion like mumps parotitis also in the peptic ulcer appendicitis so these are the conditions where amylase will increase now again the problem is the total amylase is increased but we don't know exactly what is the source of amylase it may be salivary amylase it may be pancreatic amylase or it may be amylase from the GI tract so we don't know for sure now there is a confusion now what can be done just go and measure isoenzymes there are two isoenzymes P isoenzyme and S isoamylase and P isoamylase. P isoamylase is pancreas specific and S isoamylase is the non-pancreatic amylase. जति पनि amylase छ जुन pancreas भन्दा बाहिरको सोर्सबाट निस्किन्छ they are S isoamylase. जस्तै salivary gland, fallopian tube, lungs, etc. तर अब P isoamylase is only present in pancreas. So it means that in acute pancreatitis only P isoamylase will be increased whereas in other condition where the pancreas is not involved like salivary gland fallopian tube lungs non pancreatic amylase also called S isoamylase will be elevated so in this way we can easily identify the cause finally let's see about the application of enzyme now there are diagnostic uses therapeutic uses and analytical reagents diagnostic use को बारेमा त भर्खरै पढ्यौं isoenzymes they can be used for the diagnostic purpose है पनि हेरौँ सरसर्ती यो टेबलमा सबै जान्नु पर्दैन जस दुई चारवटा जाने पुग्छ जस्तै अघि पढेको आइसोइन्जाइम्सहरू नै लेख्दा पनि हुन्छ जस्तै अब डायग्नोस्टिक पर्पजमा enzymes are the basis of tissue damage marker or sometimes the tumor marker जस्तै acid phosphatase it increases in the prostate cancer alanine aminotransferase in the liver disease aldolase in the muscle disease amylase in the acute pancreatitis MOMSहरू भयो creatine kinase in the myocardial infarction muscle disease जस्तै 5' nucleotidase in the hepatitis obstructive jaundice prostate specific antigen in the prostate cancer trypsin in the pancreatic disease cystic fibrosis so these are the examples है अब मैले यो सबै भनिन you don't need all these things पछि प्र्याक्टिकलहरू गर्दाखेरि पनि यो सबै कुराहरू आउँछ so this is how we can use enzymes for the diagnosis of various kinds of disease त्यस्तै अर्को छ थेराप्युटिक युज भनेको फर द ट्रिटमेन्ट पर्पज त्यसको लागि अब यहाँ धेरै नै छ तर म सबै भन्दिनँ जस्तै स्ट्रेप्टोकाइनेज इज एन एन्जाइम इट इज युज टु डिजल्भ द क्लट अर पुरुलेन्ट मेटेरियल सो इट इज युज्ड अगेन्स्ट अ थ्रोम्बोलाइटिक थेरापी जस्तै ब्लड भेसलमा अननेचुरल ब्लड क्लटहरू भयो हैन स्ट्रोक भयो इम्बोलीहरू भयो थ्रोम्बसहरू एकुमुलेट भयो भने स्ट्रेप्टोकाइनेज दिइन्छ यसले के गर्छ त त्यो जुन क्लटलाई डिजल्भ गर्ने काम गर्छ र त्यो ब्लकेजलाई रिजल्भ गराउने काम गर्छ अर्को भनेको पुरुलेन्ट मेटेरियलहरूलाई डिजल्भ पनि गराउँछ यसले पस जस्तो एकदम पिप निस्केको ठाउँमा गए त्यही जम्मा भएर बस्छ ढिक्का जस्तो त्यसलाई डिजल्भ गराउने पनि काम गर्छ स्ट्रेप्टोकाइनेजले त्यसै गरी अरू पनि छन् पेनिसिलिनेज छ इज द ट्रिटमेन्ट अगेन्स्ट पेनिसिलिन एलर्जी ट्रिप्सिन छ it is used to cleanse the wound by dissolving purulent material and against the thrombophlebitis thrombophlebitis means blood clot and inflammation of the vein and hyaluronidase भन्ने छ it promote rapid absorption of drugs injected अनि अर्को कोलाजिनेज छ used in the debridement of dermal ulcers and severed bones renin छ used for treatment of gastric acylia भनेको acid production नहुने त्यस्तै अरू पनि छ थुप्रै यु डोन्ट नीड अल दिस थिंग्स सबै जान्नु पर्दैन जस्ट आफूलाई जुन सही लाग्छ दुई चारवटा त्यति जाने पुग्छ कोलाजिनेजको भइहाल्यो युरिक एसिड इज युज्ड अगेन्स्ट गाउट राइबोन्युक्लियस इज युज्ड अगेन्स्ट एन्टी भाइरल थेरापी recombinant adenosine deaminase is used in the severe combined immunodeficiency disease जहाँ चाहिँ एडीए डिफिसियन्सी हुन्छ त्यसमा recombinant एडीए हामी दिन सक्छौं so these are the applications of enzyme therapeutic application it means enzyme are used for the treatment purpose finally analytical reagent not only for the diagnosis and therapy they can also be used in the laboratory for the assessment of different analytes in the blood, urine and various biological samples. For example, alcohol dehydrogenase is used for the detection of ethanol poisoning, lactate dehydrogenase for the determination of lactate in the blood, glucose oxidase peroxidase for the determination of glucose, uric acid for the determination of uric acid in the blood, just the cholesterol oxidase peroxidase in the determination of cholesterol, lipase, glycerol kinase, phosphate dehydrogenase in the determination of triglycerol. So these are the different parameters in the blood which can be assayed or which can be measured by using different enzymatic reagents. So this is all about enzymes. So I hope you have understood this. So हामीले के पढ्यौ isoenzymes and their role त्यसको बारेमा पढ्यौ त्यसपछि different isoenzymes हेर्यौं amylase हेर्यौं alkaline phosphatase हेर्यौं हैन acid phosphatase हरु हेर्यौं creatinine phosphokinase CPK हेर्यौं LDH को बारेमा हेर्यौं हैन CPK has 3 isoenzymes LDH has 5 isoenzymes त्यस्तै गरी amylase has 2 isoenzymes हरुको युज गर्यौं त्यसपछि some application of enzyme where we learn about how enzymes can be used for the diagnosis of different disease त्यसमा enzymes हरुको र त्यसको डिजिज सँग के रिलेसन छ भन्ने कुरा हेर्यौं then we saw about the therapeutic application of enzyme where we used enzymes for the treatment of different conditions or different wounds अथवा चाहे त्यो एन्टिब्याक्टेरियल होस् चाहे हाम्रो आफ्नै कुनै कन्डिसनलाई ट्रिटमेन्ट गर्न होस् त्यसको कसरी युज गरिन्छ कुन कुन इन्जाइमहरू हामीसँग अभाइलेबल छ क्लिनिकल्ली भन्ने कुराहरू हेर्यौं and finally we saw the use of enzyme for the analytical reason where I used determination of different biochemical parameters or analytes in the blood. So यति नै हो आजलाई र केही छ भने सोध any confusion up to this point? Does anyone have any confusion?